What's up? What's up? What's up, everybody? Welcome, welcome, welcome. I am Carmen. If you are not familiar with who I am, let me tell you a little bit about myself. I equip educators, just like you and like me, with the tools and the strategies they need to get past their limiting beliefs and support all of their learners. Too often, we want to focus on one group. And instead of focusing on that one group, we need to make sure that we are hitting all of the babies that are entrusted in our care. So I can help you with that. Today, we're going to be talking all about focusing on the concrete, the pictorial, and the abstract when it comes to mathematics. Because sometimes we get stuck in one of those stages, and we'll talk about what each one of those is in a little bit. Because if we're really going to hit and support all of our babies, then we need to move through these stages. Before we do that, though, I want you to take a second and I want you to think about your limiting beliefs. What beliefs do you have that are not just limiting yourself, but they're limiting your students? Because you see, it's a mindset thing. If you think one way, then that's the way you're going to teach, and that's the way that you're going to show up for your kids. Now, that might not always have the best impact on the students that you teach. So take a minute, pause the video. What are your limiting beliefs? Jot them down so that we can take those and turn them into something else, something a little more positive. Now that you have done that exercise, you are ready to hit the hay and keep it moving. Now, one limiting belief that I've heard a lot from various educators is, well, that's the way I've always taught it. Just because you taught it like that, does that make it the most beneficial and effective for your kids? Think about it. Another one I've heard, that's how I learned it, so that's how I'm going to teach it. But as teachers, we have to be willing to evolve and to grow so that we make the best impact on our students. So we can't focus on the way we learned it, because let me tell you something. In my 30 years here on this, 30 plus, in my 30 plus years on this earth, I have seen recently a lot of people who lack number and number sense and who just struggle with math. It's because they did not have that teacher who taught them the way they should have learned it, myself included, back in the day. Now that we know more about mathematics, let's use some of these research-based strategies so that our students now, when they get to adulthood, they're not struggling. We want our students to become successful at math now so that when they get to 30 plus years, or when they get to however old, no matter what job they have, they're going to need to use some type of math. So we want to equip them now with the strategies that they need so that when they get to have to apply it in the real world, then they are able to do that, because as elementary teachers, we gave them the strategies that they needed. So today, we're going to talk about the concrete, the pictorial, the abstract. I'll show you some examples of each one, and then we will talk about how you can use those in your classroom. So what is the concrete? Well, the concrete, when we're talking about mathematics, is just those hands-on strategies that you should use. Now, let me tell you something. I don't care what concept you're teaching, there is a hands-on strategy that you can use to teach it. You just have to be willing to figure it out.
Let's review. Again, the concrete is when students have opportunities to use those hands on mathematics strategies. Looking at the first picture, you see that students are adding fractions with like denominators. They're doing that with pattern blocks. They can see the whole, they see what the size of a unit fraction is, and then they get to see what it looks like when you put two unit fractions together, or you put those pattern blocks together to make the whole. In the second picture, you see students are creating lines of symmetry using Play-Doh as their manipulative. They have created a line with the Play-Doh, and they are using that Play-Doh line or that line of symmetry to see how many lines of symmetry different objects have. You can see how we can use concrete strategies no matter what grade level we are in. The first picture with the fractions is actually a third grade lesson. The symmetry activity was a second grade lesson.
Now, on to the pictorial or representative. That's when we take those concrete strategies that we've been using and we take those, and now instead of using our hands on manipulatives, we are drawing pictures of how we moved our hands on or concrete manipulatives, again, so that our students have access, so that we understand what we're doing.
On to the pictorial, again, that is just drawing pictures to go along with what we learned in the concrete. You can see in this picture, you see two examples of students adding fractions. The first one, again, students are adding fractions with like denominators. They put them together to create a improper fraction, and then they are able to draw a picture, again, the pictorial model of an improper fraction to create a mixed number. In the second picture, you see, again, students are adding fractions, but they are adding fractions with unlike denominators, and then they have to simplify. The first picture is from a third grade lesson, and the second picture is from a fifth grade lesson. So it doesn't matter what grade level students are in, their strategies are going with them, and they're able to use that concrete or that pictorial to help them no matter what grade level they're in.
And finally, the abstract, that's just your basic standard algorithm. That's the way that you or I learned math back in the day. That's the carry the one, the add a zero here when I'm multiplying multi-digit numbers. That's your algorithm. And we want our students to get there, but we want them to get there on their own.
Again, the abstract, it's just the algorithm. It's the way you or I learn to do it. You see 5/8 plus 3/8 equals 8/8 or one whole. After students have had time to explore with their manipulatives, then they'll easily be able to see that. The same in the second picture, again, we're adding fractions, but we're just using the algorithm. Both of these, again, are a third grade and a fifth grade lesson. Because our students have had time with the concrete and the pictorial, they're ready for that abstract strategy.
That's why we have the concrete, the pictorial, and the abstract. I personally believe in teaching students the why so that after we get past the why, they can move to the how on their own.
Let's do one last review. Again, you have the concrete, the pictorial, and the abstract. In the picture there, you can see how they kind of all fit together. We start with our manipulatives, and then we draw pictures of them, and then we have our algorithm or our abstract strategy so that we are successful now because we understand why. We started with the why, and now our students are at the how. They understand how the algorithm works. Using the concrete, the pictorial, and the abstract gives us a deeper understanding and a more conceptual understanding of mathematics so that we don't struggle later. Also, remember, when you're teaching the concrete, you want to start teaching that in isolation, but eventually you want to put that pictorial model in with the concrete. And then you're going to move from the concrete to teaching the pictorial and the abstract together. You want to put the algorithm beside that picture so that our students can see what the picture looks like and how it relates to the algorithm.
Teaching in 2020 is definitely different. And I know it can be a struggle to think about trying to use concrete strategies in the virtual world, but it's possible. Using the pictorial in the virtual world is possible. And of course, using the abstract in this virtual world is possible too. You have so many resources as far as hands-on learning. There are interactive Google Slides you can create. There are virtual manipulatives out there that you can definitely use to help you create that hands-on experience in the virtual world. I have also found that using the virtual manipulatives or the interactive Google Slides are helpful because they kind of bridge the gap between the pictorial and the concrete because students have the hands-on capabilities, but they're 2D images, so they're flat just like their pictures are. So it's easier almost for them to draw a picture of the manipulatives, the virtual manipulatives.
Here's just one example of how you can use Google Interactive Slides to create those virtual manipulatives and kind of move to the pictorial with that. On the side, you can see all of the place value discs that the student used, and on the place value chart, you can see how they have lined them up and they are ready to add their number. When I'm ready to move on to the pictorial, I can easily see what this picture in front of me looks like with my virtual manipulatives, and then I'm ready to draw a picture on my paper so that I can easily solve the problem.
I want you to think about all of those things when you are planning your instruction, especially for mathematics. How can I make this a hands-on activity for my students? What strategies are out there? I promise you, if you Google it or you go to YouTube or wherever, you will find a concrete strategy for everything. Yes, you can multiply multi-digit numbers concretely. Yes, you can um, figure out the expanded form concretely. There are strategies out there. There are resources out there. You just have to be willing to look for them. And I betcha you can find them right here on this site too. Thanks so much for watching this video. Don't forget, as you are planning for your mathematics instruction, please make sure that you take some time to move from the concrete to the pictorial before you're moving to the abstract. As a matter of fact, let your kids get the algorithm on their own. Try it. It works.